In this video, I want to talk to you about how to calculate the G-spread and what the G-spread actually is. This is a topic coming from the fixed income section of the curriculum, and if it's something you want to get right in the exam, do keep watching and let's get solving. So this is the question which I want us to have a go at. An analyst gathers the following information about two bonds. You've got a German government bond and a German corporate bond, both with the same maturity, different levels of coupon, and different prices per 100 of par or 100 of nominal value. And we're asked to compute the G-spread of the German government bond and what is it closest to. Right. This is a relatively easy thing to do if you know how to compute the yield to maturity on a fixed income instrument using your preferably Texas Instruments BA2 Plus calculator. Let me just explain that the G-spread is basically the spread over the government bond yield, hence the G in the name, government bond yield. And this is simply going to be, in the end, a difference in yields to maturity for the two bonds. Hopefully, what will come out is that the German corporate bond will have a higher yield to maturity than the German government bond, and we'll just compute the delta, the difference, and that's going to be the answer. Okay, so we need to set this up on the calculator. Let's get cracking. So let's start with the government bond first. And obviously, I'm looking for its yield to maturity. So I'm going to utilize the time value of money worksheet on the calculator, which is that third row from the top with its distinctive, typically slightly different coloring than the other keys. And I'll just input the relevant parameters. So obviously, in any order you wish, you can do this, but I'm going to have n set up as 5 because it is a 5-year bond. Let me remind you that when you provide inputs into the time value of money worksheet, you actually first input the value. So in this case, it's going to be 5, and you follow this up with the relevant key, such as n in this case, to tell the calculator that n should be equal to 5. Now, the next thing I want to do is tell the calculator what the price of the bond is, and that's going to be the PV. 102.67 for the government bond, 102.67. However, make this a negative value so as to tell the calculator it's the price we're paying. So PV, that's the parameter. Now, in terms of the PMT, that's going to be the coupon. I'll set this at the coupon for the German government bond, which is 4% or 4 PMT. And obviously, I need to tell the calculator what future value is going to be, so how much this bond has in terms of par value that we get at the end of its life, and that will naturally be a nice round 100. So 100 for FV. You will have noticed me doing this as 100 FV. However, over here I'm writing the parameters down as FV equal to 100. So I think I've got everything in place. Let me now compute for I over Y. So CPT compute I over Y, and this yields a result of 3.41% roughly. So that's the yield to maturity on the government bond. Let's repeat the same steps for the corporate bond. And actually, I'm going to utilize the fact that my calculator already has many of the inputs in place. For example, the corporate bond also has a 5-year maturity, and its FV is also going to be 100. The things that are going to be different are obviously the price. So I'm not going to change all the inputs. I'm just going to overwrite the inputs which are indeed different. So price for this bond is 96.48. Let me input 96.48 plus minus key to turn it into a negative figure, followed by PV. Good. The PMT, the size of the coupon, is different. It's 6%. So I'm going to set PMT at 6. So I do this as 6, followed by the PMT key. Everything else is the same, so I can now ask my calculator to do the computation of yield compute CPT I over Y. And my calculator is telling me it's 6.86%. Good. In order to actually now get the G-spread, we need to compute the difference between the two yields. So G-spread is this 6.86% minus this 3.41. Let's see what it actually is. 6.86 minus 3.41. That gives 3.45%. And I guess this is very much in line with answer B, which says 345 basis points. A basis point is 100th of a percent, so this is the same.